We now move to the second part of the chapter, that is the first law of motion and inertia. Now, we understood that whenever any particular body is going to be in motion, or when you are making it to be in motion, we need a force. So, one thing was very clear, that if I want to start something and make it move, then I need a force for it to change its state of rest to motion. But when we see further, like when we are cycling, doesn't just happen that I start the pedaling and then the cycle just goes by itself and I don't need to do anything at all. No. It so happens that every time you need to keep on giving that force so that your body is going ahead. So accordingly, it was seen that we always find that force is not only required to start an object, but it is also required to maintain that particular motion. So earlier everything was considered this way, that you need force not only to change the state of rest to motion, but also to keep the body in motion. But then Galileo, okay, he was not so comfortable with this particular results. He said that no, it is not possible that you need to keep on giving the force over there. So if you have something, or if you have a particular medium where there is no frictional force, or there is no force due to resistive force due to the wind, or there is no resistive force for the motion to take place, means there is no air, there is no friction, so it's in vacuum. In such a condition, if you set a body in motion, it will remain in motion throughout, irrespective के उसको बाद में force मिला या नहीं मिला. So the body will have the tendency to keep on traveling, it keep on moving in a straight line unless and until somebody has stopped it or some external force is given to stop it. So we say the body is going to remain in a state of motion unless and until an external force is given to that body. So that is what Galileo said. That you need not have a force to keep that particular body in motion. So then why do we need to keep on cycling? Because when I cycle, I just don't need to put the pedal, and then I need further also. Same way, petrol का गाड़ी भी रहेगा, चालू कर दिया, एक बार पुश कर दे, फिर अपने आप चलनी चाहिए ना. Why do we need to keep on accelerating and things like that? Why do we need to do that? The reason is the resistive forces. On normally, each and every body, when it is moving, it is going to produce a opposite force that we just learned in the previous video, that is the frictional force. So the frictional force is the main thing what needs to be overcome each and every time some motion is taking place. Secondly, there could be some resistive force by the wind, or maybe some kind of a resistive force due to gravity also, right? So there would be some kind of a resistive force which will be there, which will not allow the body to continue its motion. If you are able to get rid of these resistive forces, then automatically there will not be any requirement to give a continuous force to that object for its motion. So that's why we say that Galileo, we need not read the complete part, it is not so, because it's just an example over here. So we'll just read the second thing, the second column of the first page, that is, Galileo did not approve the above view. From his experiments, he found that no force is needed to continue the motion of a moving body. If a body is set in motion, it will remain in motion even when the force applied to set the body in motion is withdrawn. provided that there is no other force such as friction, etc., to oppose the motion. From our everyday life experience, we know that a cycle does not stop at once as we stop pedaling, but it moves a certain distance before coming to rest. If in fact it stops due to force of friction between its tires and road, and also due to friction between its moving parts. If friction between its moving parts is reduced by proper oiling or greasing, it is made to move on a smooth road. It travels comparatively as much longer distance before coming to rest after pedaling is stopped. So that's what they say, that yeah, if that would have been the condition, that it would stop immediately as soon as the pedals are stopped. Means if we prove that the force is required continuously to keep it in motion, then what would have happened is that as soon as I release if I stop pedaling, it would stop immediately. But it is not so. As soon as I stop pedaling, it will still go a further distance, and depending upon what is the kind of the road, if the road is very smooth, if my cycle is very well oiled and greased, and all the parts are very almost frictionless, then it will continue to go a longer distance. So because the friction will be between the tire and the road. You will always find that when you see some cycling race going on, the cyclists who are be over there, the cycle over there has got the tires which are very thin. You can see the very high cost kind of cycles which are for speed. They will be having a very thin tires. So tires are very thin, and that too the pressure in the tire is so thin, so high, that the only contact between the tire and the road will be just a very small thing over here. It's only this much. Okay? Why is it so? So that the friction between the road and the tire is minimum. Hence, that particular cycle can go at a very high speed. Okay? Yeah, this was just an example for you. So we see that if somehow it would... Okay, I missed it. Yeah, if friction between the moving parts is reduced by proper oiling and it is made to move in a smooth road, it travels comparatively much longer distance before it comes to rest after pedaling is stopped. If somehow it would have been possible to reduce the force of friction completely, the cycle would have remained in motion forever even when the pedaling is stopped. Thus, it is concluded that in the absence of force of friction, no force is required to keep any object moving after bringing it in motion. So once the frictional force, which is the most important resistive force, if that is made minimum or it is reduced to zero, then we can say that no force will be required for running that particular cycle at all. The body, so in other words, an object, if once set in motion, moves with uniform velocity if no force acts on it. So it can be stated that once a body is made to move, then it will continue to travel with uniform velocity once it is set in motion if no force and resistive forces are available over there. Thus, the body continues to be in a state of rest or in a state of uniform motion unless an external force is applied on it. This is nothing but Galileo's law of inertia. Okay, so this is what is the first thing, that is Galileo's law of inertia. Now, the law of motion by Newton the laws of motion are by Isaac Newton. So Isaac Newton gave the laws of motion. But the first law of motion is dependent on something which is called as inertia. And this inertia was discovered by Galileo. So Galileo was a person who discovered or who found out the inertia, and hence he gave the law of inertia as the Galileo's law of inertia. And from our discussion we know that if a body is at rest, it remains at rest unless a force is applied in it. And if a body is moving, it continues to move with the same speed in the same direction unless a force is applied in it. So that is the law of inertia. The law of inertia states that if the body is at rest, then it will remain at rest unless a force is acted on it. That is the first law. And the second thing is, if the body is in motion, it will remain in motion in the same speed, in the same direction, unless until no external forces applied on it. So this is the two laws. Now these observations were taken up by Newton. So Newton, he took these observations and he formed the first law of motion. So the first law of motion is law of inertia. So the first law, so it is first law is given by Newton. So Newton's first law states that according to Newton's first law of motion, if a body is in a state of rest, it will remain in a state of rest, and if it is in the same state of motion, it will remain moving in the same direction with the same speed unless an external force is acted upon, force is applied on it. So that is the law, that every body will remain in a state of rest or of uniform motion in a straight line unless a force is acted upon it. Or as per the textbook, if we say that Newton's first law states that if a body is in a state of rest, it will remain in the state of rest. If the body is in a state of motion, then it will remain in a state of motion in the same direction, with the same speed and the same direction, unless an external force is applied on it. So till the time I do not apply an external force to that particular body, that body is not going to change its state of rest or motion. But for example, if I place something over here and keep this for over here, unless and until I do not move my hand out, this will remain as it is. So if suppose in this room, particular room, if I place a pen over here, अगर मैंने कहीं पे भी ऐसे पेन रख दिया, तो वो पेन जब तक कोई और, if there is no other force applied on it, it is going to remain over there at a state of rest. Similarly, if I, like for example, if I am going to have a particular a road which is absolutely smooth, which has no friction at all, and if I just push a car over there, the car will remain in that particular move in the same direction, in the same speed, unless and until it is acted by an external force. So this is the first law of motion, that if a body is in a state of rest, it will remain in the state of rest, and if it is in the state of motion, it will remain in moving in the same direction with the same speed, unless an external force is applied on it. Okay, so this was about the first law of motion by Newton. Now the Newton's first law has got 2 points, or we can say it is going to help you, or it is going to give you 2 readings, or it is going to give you 2 studies. The first study can be understood in 2 parts. The first part is inertia. So first part is inertia, and the second part over here is the definition of force. So the first law is understood by 2 parts. One is in the definition of inertia, and second is by the definition of force. So let's understand by the definition of inertia. So what is inertia? Inertia, we know that object is going to remain in a state of rest, or it is going to remain in a state of motion. So again, the same thing. So Newton's first law gives the definition of the inertia, according to which an object cannot change its state by itself. If the object is in state of rest, it will remain in the state of rest. If the body is moving in the same direction, it will continue to move with the same speed in the same direction unless an external force is applied on it. So example, a book lying on the table will remain on the table unless until somebody doesn't come and keep it in the outside. Or if you have any kind of a ball rolling in a plane, and that plane is absolutely free from friction, then the ball will keep on traveling over there unless until some external force is applied on it. So these are the property of a body by virtue of which it neither changes its state nor it tends to change the state. is called as inertia. So here, the first thing what the law does is defines inertia. So what is inertia? It is a tendency or the property of the body by which it is going to remain in a state of rest or remain in a state of motion. So that particular tendency is nothing but inertia. So a property of a body or an object by virtue of which it neither changes state of rest nor it tends to change the state, it neither changes nor it tends to change. So neither it changes or nor it tends to change. The state is called as inertia. It is an inherent property of the object. So inertia is the inherent property of that particular object. The second thing what we define is force. The first law also defines a force. So the second part of the Newton's first law defines a force, according to which force is the external cause which can move a stationary object or which can change the state of motion of a moving object. So here you can see force. What is force? It is that force. Force is that physical quantity which is changing the state of inertia of a body. Body has a tendency to remain over here. Force is the one which is moving it. Body has a tendency to move. Force is the one which is stopping it. Body is moving in a straight direction, but the force is the one which is going to change the direction. So what is the force? Force is that external cause. Okay, force is that external cause. So force is that external cause which can move a stationary object or which can change the direct state of motion or of a moving body. Okay, so to move a body or to change the state of motion of the body, you need that external cause, and that cause is nothing but the force. Hence you define force is that external cause which tends to change the state of rest or of state of motion of a object. So that's why we see that the book lying on the table gets displaced when somebody has pushed the table or pushed the book, or the bicycle stops when the brakes are applied. So all these are examples of the force, and we know that force is a vector quantity. The sum of the two equal forces is 0. So we know that forces, if they are in opposite direction, then the sum of the forces will be 0. That's why it's a vector quantity. And the body acted upon several forces can also have a resultant net force on it equal to 0. So if, like in the take a tug of war, कितने सारे forces act हो रहा है, फिर भी क्या वो उधर का उधर ही अगर है, तो what is that? Number of forces acting on it, but the sum of all forces can be 0. So that is what is about the force over here. Now we see about the relationship between the mass and inertia. So it's always seen that the inertia of a body is dependent upon the mass of the body. If the mass is more, inertia is more. If the mass is less, inertia is less. Simple example. You go to Big Bazaar or a D-Mart or any kind of a thing. So what do you take first over there? A trolley. That trolley, when it is completely empty, how easily do you maneuver that trolley? Very easily. You are pushing it without any problem. So you are, in fact, you are not telling your mom to carry that trolley. You yourself are carrying the trolley because you are having the fun of moving it here and there, right? Because it's very light. So mass of the trolley negligible at that time. So the movement very easy. So to change its inertia is very easy. What happens when mommy loads that trolley with all the different stuff? Is it now easy to move the trolley? No. Because now as the mass increases, the trolley's inertia increases. Hence to overcome that inertia, you need more force. Right? Because force is the external cause for motion. So if the inertia is more, the cause to break inertia will be more. Right? So automatically what happens? More amount of force will be required if the mass is more. So inertia is the inherent property of each body by virtue of which it has tendency to resist the change of state of rest or of motion. The property of inertia is because of the mass of the body. The greater the mass, the greater the inertia of the body. A lighter body has less inertia than a heavier body. In other words, more the mass of the body, more difficult it is to move the body from rest or to stop the body it is initially in motion. Thus, mass is a measure of inertia. So, you can see over here that they are given an example of a cricket ball and a tennis ball. So, cricket ball is that season ball and the tennis ball is the light ball. So, a cricket ball acquires much smaller velocity than the tennis ball when the two balls are pushed with the same force. So, if I am hitting a cricket ball with the same force, if I hit the tennis ball will go much faster as compared to the cricket ball. Why? Because the inertia of the cricket ball will be the cricket ball being heavier than the tennis ball, the inertia of the cricket ball will be much greater than the tennis ball. Hence, it will require more force. If I am applying same force on the cricket ball as well as the tennis ball, then with the same force, the velocity which I get on a tennis ball will be much greater than the one which I get on the cricket ball, because cricket ball being heavier has got higher inertia. So in case when they are moving with the same velocity, it is more difficult to stop the cricket ball which is more mass in comparison to a tennis ball. Same way, if the tennis ball is coming over here, तो उसको रोकना easy है. Okay, because it's only having a speed, but with the same speed, they're coming with the same speed. Then to stop a tennis ball is easy. But a season ball, if it is coming to you, then what happens? You to डर लगता है, हाथ में लग जाएगा, right? Because the inertia with which it is moving is higher, so the force required to stop it will be higher. Okay, so that's why it is going to be difficult to move a cricket ball as compared to the tennis ball. Similarly, is the case of a trolley, loaded trolley. So in motion, it is difficult to set a loaded trolley in motion and then an unloaded trolley. Similarly, it is difficult to stop a loaded trolley than to unloaded one if both are moving initially with the same velocity. So this is how we can have the difference, or we can say the comparison, or how inertia is dependent on the mass. So inertia is dependent on the mass of the body. More the mass, more the inertia, lesser the mass, lesser the inertia. Now we are going to see certain simple examples in our day-to-day life about about the use of the first law of motion, that is the law of inertia. Now for this we will see that there are two kinds of inertia which is going to be present in our day-to-day life. One is inertia of rest, and the second one is inertia of motion. So we'll be having different examples for inertia of rest and inertia of motion. So we see over here for inertia of rest. Now if a body is at rest, then it will remain in the state of rest until an external force is applied on it. That is nothing but the inertia of rest. So inertia of rest can be defined as, if the body is at rest, it will remain in a state of rest unless an external force is applied on it. So accordingly, we have got certain examples. One is, okay, we very well know that we are traveling in a train, or maybe when you are traveling in a bus, or even when you are traveling in your car and you are stationed or you are stationary, and then suppose that car suddenly picks up. Suppose you are sitting in a car and you are at a signal, and as soon as the signal opens and your car just picks up in a very high speed. So if it is going to pick up the high speed, what will happen? You are going to push backwards. Okay, so ऐसे बैठे रहेंगे, car जैसे आगे जाएंगे, तो you are going to be backwards. Similarly, if you are standing and the bus starts, you are going to go backwards. Why does this happen? This is because of inertia of rest. Now, suppose let's take this as the body, okay, this is the floor and this is the body. So this body is resting over here like this, okay, this is how it is resting. Now, when the body is resting over here, the foot is in contact with the bus, okay, the vehicle. So when the vehicle moves, what is going to happen? The body initially was at the state of rest. The bus was at the state of rest. So everything is in the state of rest. So everybody has got the state of inertia of rest. Now the body moves. When the body moves, what will happen? With the motion of the bus, the feet which are in contact with the bus, they are going to get the inertia of motion, but the upper part, they will take some time to take the inertia of motion, and hence they are still at rest. So they are still remaining at this position, and the body moves, lower part of the body moves forward. So actually what has happened, you have been pushed backwards. Got it? So the backward movement which has taken place over there is because your lower part of the body was in contact with the moving body. The moving body, when it moved, it went from inertia of rest to motion, whereas the upper part remained in the inertia of rest, and hence it gave you a backward push. Okay? So when a train suddenly starts moving forward, the passenger standing in the compartment tends to fall backwards. So this is what I just explained you. The next thing is, when a hanging carpet is beaten with a stick, the dust particles start falling out of it. So that is the next part. That is, if I want to, now you must have seen many times that when you are dusting a particular carpet, what do? You take that particular carpet और उसके बाद एक लकड़ी लेते हो और उसके बाद इसे bang करते हो. So when you bang it, you will find the dust particles coming out from here. How does that thing happen? Again the same thing. The carpet is there. Carpet has got dust inside. The carpet and the dust, they are not in complete contact with each other. They are just resting over there. So the moment you are hitting the carpet, when you hit the carpet, the dust particles which are in the inertia of rest, they will remain in the inertia of rest. The carpet gets the inertia of motion, they push this way. The particle which was here is still over here only because it was at rest. And then there is nothing in contact with it, so it falls down. Got it? So it was here, मैंने इसको हटा दिया, तो ये यहीं पे है, तो ये नीचे गिर गया क्योंकि उसके पास अभी कोई contact surface nahi hai to hold that original carpet. So when you hit the carpet, the particles are not going to come into the inertia of motion because they are not firmly fixed with the carpet. If some dirt particle is firmly fixed with the carpet, then it is not going to happen. Nothing is going to happen to that dirt particle. It will remain as it is. But the moment it is freely suspended inside, it is when you hit it, it is going to fall down. So that is how when hanging carpets are beaten with a stick, the dust particles start falling out of it. The third thing is, on shaking the branch of a tree, the fruits fall down. Same thing. Suppose there is a tree and there are fruits which are hanging like this. Okay, suppose this is a branch and this is a fruit hanging over here. Now when I bring this particular tree into motion, so if the tree is that weak enough that I can push it or I can shake it. So when I shake it, what is going to happen? This fruit which is over here, it is not completely firmly fixed with the branch. So when the tree moves, this is still in the rest of motion. This is still in the inertia of rest, whereas the tree is in inertia of motion. So what happens? This is going to remain here, but the branch is going to move, and hence it is going to make it fall down. So normally, fruits fall off very rarely with this kind of thing, unless and until they are very, very tiny, like the berries and all. But when you take flowers, the flowers are very easy to fall off when you are shaking the tree. So this is how and that is why even when wind blows, the flowers get blown off very easily. So this is why the jerking of a branch of a tree, the fruits fall down. The next is, on striking the coin or the bottom of the pile on the carom coin, with the striker, lowest coin only moves away while the rest of the pile remains intact. You must have seen many times. Coin के ऊपर point के ऊपर coin रख दिया, 4, 10, 15, 5 coin रख दिया, and then you strike the striker on the lowermost coin. What will happen? The whole coin का bunch is not going to fall off. अगर fast मारा रहेगा तो वो पूरा नहीं करेगा, सिर्फ नीचे का coin stick करेगा, and ये पूरा का पूरा stack ऐसे बैठ जाएगा. So it is just that the stack was big. As soon as you hit it, the lowermost coin is gone, and so 5 out of 5, the last one has gone out, but the 4 is just going to remain in the stack on the same place. Same reason. When you hit, the lowermost one got the inertia of motion, but the upper one was still at the inertia of rest, hence they just settle down on the same spot. So this is how the lowermost coin only moves away while the rest of the coin piles remain intact. Another example over here is when a smooth card placed over the mouth of a tumbler is flicked sharply in the horizontal direction. The card flies off, but the coin kept over the card falls into the tumbler. So, suppose you take a glass. You must have seen this trick many times. You take a glass, you take a card on top of it. Card रख दिया, card के ऊपर एक coin रख दिया. ये glass है, glass के ऊपर card, card के ऊपर coin. And then you hit the card. So the card flies off. And the coin doesn't fly off with the card. It falls inside the tumbler. Why? Same reason. Coin, inertia of rest. Card, inertia of rest. Both inertia of rest. Hit the card, card moves with inertia of motion. Card moves, the coin is now having the inertia of rest only because it is not in direct contact with the card properly, and hence it falls into the tumbler. Okay? You must have seen many magicians are doing that particular trick. Ke pura ka pura table is being set and the cloth is also there, and then he just pulls off the cloth and everything on the table, the dishes and everything just falls on the table. Don't try it at home. All the cutlery are going to fall down. So that is why it is only the magician who can do that thing. It is very swift work of the removing of the particular thing. Moreover, also the kind of the cloth they use will be silkish, so that it is not having too much of a friction between the things which are kept over there and the table. Otherwise, what will happen when you're pulling it? Normally what will happen is that when you're pulling it, the items will be pulled along with it because of the friction being too high between the cloth and the objects over there. So that is how it is going to be flying off. And the last one is when a corridor train suddenly starts, the sliding door of some compartment may be open. Now you must have seen this thing. Corridor train तो पता नहीं रहेगा तुम लोग को, very rarely must have traveled that way. But you must have seen a Maruti van, the van which is there, which has got a sliding doors. So you will always find that when the sliding doors are there, so even if the stores are open, and when that particular person, the driver, starts the car and suddenly brakes, the doors are going to close by itself. So that is basically, so when that particular car is the particular doors which are there, when it starts, so if the direction of the motion of that particular car is such that the doors are going to be closing this way, so that is what exactly happens in the compartment train. कि ट्रेन का जो कंपार्टमेंट का जो दरवाजा रहता है, that is on both sides, it's closing on both sides. So when the train starts, so ये वाला जो दरवाजा है, it is going to come, which is going to close because it is going to be at rest. So when the train starts, it is just going to be pushing out. The train goes ahead, but the door remains here only. Hence the train goes ahead and the door closes. So this is how the corridor train suddenly starts. The sliding door of some compartments may open. So this was about the inertia of rest. All these examples are very, very important for give reason. So give reason kind of questions, you need to learn this thing for the answer. And each and every answer should be accompanied by the law which is representing it. Means if you are asked this particular question that why or hanging carpet will beaten the particles fall off, so you will write according to the first law of motion. That wording should be there in your answer. पहले लिखो बाद में लिखो, पर कहीं ना कहीं पे वो आना चाहिए that it is according to the first law of motion. We see the next thing is inertia of motion. So when the body is in a state of motion, it will remain in a state of motion. So, and in the same speed and in the same direction, that is inertia of motion. So the property of body to be in the inertia of motion is going to be seen in some examples over here. First is a cyclist riding along a level road does not come to a stop immediately as he stops. Of course, cycle चलाते रहेंगे, एक ही जगह पे है, उसने pedaling बंद किया तो भी वो cycle आगे जा ही रहा है, because the inertia of motion is there. So the body is going to tend to remain in a state of motion unless and until acted by an external force. Similarly, when a passenger jumps out of a running train, he falls off. You must have seen that many people, when they want to get down off a running train, they run along with that particular train. So they get down and while getting down, they run with the train. Why do they do so? Because see, when they are running, the train is coming over, the train is going here. Now this is the platform. Now when they come over here, and if they jump, when they jump, your upper body, the whole body was in the inertia of motion. So when the train was traveling at that time, this person who is standing over here, he is reaching the station and he reaches the station at that time, he just jumps over here. When he jumps from here to here, at that time, this person is in the inertia of motion. So his body is in inertia of motion, which direction? In this direction. So when he jumps over here, his lower part of the body comes to rest. But the upper part is still in the direction of inertia of motion. So that's why when he jumps over here, he will tend to fall down. So what is the alternative? When he is coming over here, he will get down with one foot and he keep on running in the direction of the train. So when he is running in the direction of the train, he is allowing time for his body to get completely in control of the inertia of motion and rest. So he gets the control over his body against the inertia, and he sees to it that he can control the body to stop himself or move himself. So that is how when the train comes over here, he keeps one foot and then he keeps on running in the same direction so that he is able to balance himself and not fall. So this is how a passenger is going to jump. When he is trying to jump, he will just fall down. So to avoid falling, a passenger feet touches the ground, he starts running. He should start running on the ground in the direction of the motion of the train for some distance. The third is, when the running car stops suddenly, the passenger tends to lean forward. That's the same thing what is there in the case of जब start होता है तो पीछे जाता है, वैसे ही अगर गाड़ी जा रही है और suddenly brake आता है, you will lean forward. Why you lean forward? Because the car is moving this way, so the whole body is in the inertia of motion, and suddenly the car stops. So the lower part of your body is still has come to rest because of the car coming to rest, whereas the upper part is still in motion and it is moving forward. So the motion is going to be seen over here, that when the body is, when the car suddenly stops, when the moving car suddenly stops, the upper part body leans forward. That is the thing over here. Now we see the fourth point, and that is, an athlete often runs before taking a long jump. You must have always seen that fast bowlers कभी भी ऐसा नहीं ऐसा करके आके फास्ट बने, नहीं, वो दौड़ते हुए आएगा और उसके बाद बॉल करेगा. Why? And the faster he runs, the faster he will be able to bowl. Why is it so? Because when he is carrying the ball in his hand and running, at that time, the ball is not in rest. The ball has gained the inertia of motion of the person who is bowling. The bowler has got its inertia of motion in him, and that's why the ball also has got the same inertia, and then when he throws the ball, it is increasing the inertia of motion and hence it is going faster. Same way, javelin throw में भी क्या करता है, दौड़ते हुए आता है और फिर वो he throws the javelin. When the hammer वगैरह throw करना तो क्या करता है, वैसे घूम के राउंड घूम के उसके बाद फेंकता है. Why? So that he is giving that particular body which is to be thrown a inertia of motion, so that it can increase the way it has gone through. So that's how that same thing, even a long jump person, a person who is going for a long jump, he will come running and then he will jump. He will not just come over here and jump like this. He will not go for a long jump like this. It's called as spot jumps. Spot jumps are never too long. Long jumps will always be when he is running and then coming and giving that particular thing. Lastly, a ball thrown vertically upwards to the person in a moving train comes back to his hand. Now this is something very important. So you have been traveling in a train. Okay, anytime when you travel in a train, you must have played some of the other kind of a catch or कुछ तो खेलते रहेंगे. So you are sitting next in front of each other. Train is traveling in this direction. One person is here, one person is here. Now when the train is traveling this direction, फिर भी हम लोग जब भी बॉल देते हैं, तो what happens? कभी ऐसा हुआ है कि मैंने बॉल फेंका क्योंकि ट्रेन आगे गया तो वो बॉल मेरे को ही लगा? It will ever happen that when you threw the ball a bit upwards, because the train was in motion, so you are here. You threw the ball upwards because the train is in motion, so the ball hit you. No, it doesn't happen. Why does it not happen? It doesn't happen because when you threw the ball upwards, at that time the train was moving in this direction, so the ball was also having the inertia of motion in that direction. And hence the ball actually, it didn't go up and down here, it actually moved like this. So it moved up and went like this because of the inertia of the motion. It was going in this direction, it was going in this direction. So actually क्या हुआ, वो ball जो है वो यहाँ पे ऊपर फेंका था, पर तब तक जब ये इधर का इधर पहुंचेगा, so the ball actually moved like this. It didn't move like this because the body was not at rest, it was moving. So when it came to your hand over here also, that means the ball actually moved like this. Okay? You can imagine this thing. Because if it would have moved like this, then when you moved here, the ball would have been left out some backwards. कितना पीछे रह गया रहेगा, वैसा होता है नहीं. You are able to play catch in the train because in the train the ball has got the inertia of motion of the train. Because it is the inertia of motion of the train, that is the reason you are able to play catch inside the train, because when you are throwing the ball has retained its inertia of motion in that direction. Okay, हाँ, if you are going to throw it upward, means train के थोड़ा बाहर आके उसके बाद ऊपर फेंकोगे तो तुम्हारे हाथ में नहीं आने वाला, because by the time it goes up, it would have lost its inertia of motion a bit in that direction, and hence when you reach other point, it is going to be left out behind. So it is not going to happen that it is going to be hit coming back to your hand if it is throwing too high in outside the train. But yes, within the train it is not going to hit you, neither it is going to be lost by your hand, because it is going to be with the inertia. So you can see that the reason is that the ball thrown vertically upwards by the person in the moving train comes back to his hand. The reason is that at the moment when the ball was thrown, it was in motion along with the person and the train. The ball was in motion along with the person and the train. It remains in the same state of forward motion even during the time the ball remains in air. So when it was in the air also, at that time it did contain that inertia of motion even when it was in air. The person inside air, the inside air and the ball all move ahead by the same distance due to inertia, and so the ball falls back into his palm on its return. Okay, so this was about the explanation of the first law of motion, that is law of inertia. Very, very important to know all these examples, and of course the law you need to learn by heart, word to word, because it's a law, it has to be written word to word from the textbook. Okay.